Hi everyone, welcome to today's topic. So this is my topic number 21, and for topic number 21 I have chosen isolable analogy. Okay, so we can say that CSIR-NET is now knocking at our door, right? So not much days are left. I have to complete my 30 topics, and I think that all the topics are very much helpful to you. So today's topic is also a very important topic and one of the scoring topic, I will say, because in CSIR-NET exam, for if each paper actually 2 to 3 questions from this isolable analogy or the concept behind the isolable analogy that you will find. Okay, so this topic is from the organometallic chemistry, and I have previously uploaded the videos from organometallic chemistry. So if you have not watched this video, please watch that first. Mainly the basic part, the 18 electron rule, how to calculate that. So that part is very important to understand the overall organometallic chemistry and each and every topic of organometallic chemistry. Okay, so right now I will just go towards my topic, my today's topic. So hope you will enjoy this session and keep patience and please listen carefully. Okay, and practice with me. Okay, so let's start now. The isolable analogy. Okay, what is isolable analogy? Thinking you are thinking this is actually you, I am comparing with your face that how you are thinking, how can be thinking. Okay, so this is actually a strategy used in organometallic chemistry to relate molecules, can be organic and inorganic. So various kind of isolable analogy can be found actually. So we will be talking about that. Mainly, it is used to relate between the organometallic molecules. Not only the organometallic molecules, so it can be used to relate also the organic and inorganic molecules. Fine. So now, how? So if isolable, what is now isolable? Okay. So for let's say two two persons are going for a walk. So how can we say, let's say friends? Okay. So how can we say that these two are friends? Okay. So that is the kind of thing. So uh, we have to see few things, right? They are how they two are actually talking and what are the similarities between them. Okay, so these things actually we have to consider. So like that, if two fragments are isolable, we have to consider few things. Firstly, the main important thing is that two fragments are isolable if they have the same frontier orbitals. So frontier orbitals, you know, right? Because I have taught you that in the Diels-Solder reaction, that class, right? So homo-lumo are the frontier orbitals. So you know now that what these are. Okay. So, but seeing a molecule or knowing only their the formula of the molecule, how can we say that what is the homo and what is the lumo? We have to draw, we have to see actually quantum mechanics actually has a very important role here. So we have to think about it, and we have to calculate actually by matrix every each and every energy levels, and then we have to fill the electrons, and then we can say what is homo and what is lumo. But the exams, you don't have that much time, right? So that's why here comes some important points that when they have two fragments have same frontier orbitals. Okay, so what will be their characteristics? So some will be their change, or some characteristics can be found. Okay, so let's see. Almost they have almost same energy, the two fragments. Fine. Should have same symmetry. Okay, both the fragments should have same number of electrons for bonding. Okay, that is the important thing, right? Because see, when first and second points we are mentioning, so when first and second point we are mentioning that is the two molecules should have almost same energy. But seeing a formula, how can we define that they have same energy, right? That is difficult. So same like to find out homo lumo and should have same symmetry. We have to know their geometry, how they are arranging in space. That is also difficult. But this point is actually helpful. Both the fragments should have same number of electrons for bonding. So if we can calculate their bonding electrons, we can actually have the idea that which are actually isolable. Okay, that is actually applicable, and that we will do for any structure. We first have to calculate their total electrons for bonding. Fine. Now, I have told you many times that two fragments. I am not telling that two molecules, because for that isolable analogy purpose, fragments are used for the calculation. Like, what is the fragment now? Fragment means parts. Okay. So, in any molecule, if we consider any molecule should have many parts, right? So we have to, let's say two molecules are given, we have to convert it to their respective fragments. Okay, how can we actually, let's say we have to cut down the structures, okay, in such a way that we can have some parts, right? And we have to compare the parts from one molecule and the part from another. These two we have to compare the fragments of both. Okay, let's, for example, let's say, I have to take the pen. Okay, let's say this image. Okay, CO. I'm just assuming. Okay, Mn CO. There are COs are present. Okay, so what can be one of the fragments? Simply, I can see that metal bonds are present. If we break here, Mn 1, 2, 3, 4. Okay, this can be one fragment. So if we calculate the electrons for bonding for this, we can have actually the idea of that how it is related to the other molecule. I will take one more example. Let's say here I am taking CH3, right? Again we can break this and fragment is CH3. Fine. So total electron count will be, okay, I will show you in the next slide. Fine. Clear? So, okay. Now coming to the case 1. Okay. There are cases, right? So case 1, let's see. Just see. So transition and main group element. So case 1 is transition. So it is actually versus, it should be. So one compound or one fragment should have some transition metal in it and main group. So what I was talking in the definition, that we can relate the organic and inorganic molecule like the same way here it is given. Okay, so for example, okay, step 1 first, what should we do? Okay, in the exam, let's say two molecules are given, one having transition metal, another having main group element. Okay, first step 1 is not this. Okay, if fragments are not given, only a big two big structures are given, that time first step is we have to find out the fragments. First thing is the fragment. Okay, fragment. Fine. Second thing is this will be step 2, total electron count, and we know this, right? If we have you have watched the 18 electron rule and the basics of organometallic chemistry, that video, you will know it in a better way. Okay, metal bond, counting of metal bond, how we can do that. Okay, that kind of thing is very much helpful here. So total electron count will be valence electron of metal plus electron contribution from the ligands. Okay, and overall negative charge if present on the complex, minus if positive charge is given, we have to just subtract it. Fine. Now step 2. Step 2 is here. It is very interesting. So this is for, let's say, the transition metal versus main group, right? So for transition metal, if the total electron count for the transition metal, it will be always the higher number, right? So if 14 electron is we can found, and for the main group, this much electron should not be there for bonding, right? So how we can compare the total electron count? We have to subtract uh, that value which we found for transition metal by 10. Okay, so it is now 4, right? Why 10? Because these are d transition metal having d electrons. So just like that, you remember this one. Okay, so this will be 4. So you should compare it with 4. So that same way, if we subtract this with 10, it will be 5. So 5. Okay, so why these two are, I am saying, comparable? Not comparable. These two will be isolable if the transition fragment having transition element or transition metal has total electron count 15. Okay, and the main group element, that part, the second part, has total electron count 5. Okay, then we can say these two are isolable. Okay, that's why I am writing like this way. These two, 14 4, 15 5, 16 6, 17 7, 18 8, like that. Okay, we can compare this with main group element. By taking an example, actually you can clearly understood this topic. This is not a very much tough topic. Okay, so let's say this one. Okay, first step is fragmentation. We have to find out the fragment. So first, let's say I am just leave the metal bond. What I got? 1 2 3 4 5 CO5 Mn. Okay, so now total electron count. We know Mn is a D5 element, D5 transition metal. So for D5, and ace electron is there, right? So 7 plus 5 into 2 for carbonyl. 2 electron count should be 2 for carbonyl ligand, right? Neutral ligand. So it will be what? 17 electron. Fine. For this, again fragmentation. After fragmentation, this will be now the fragment. Now TEC is what? Carbon. Carbon means 4, right? In the valence shell, 4 electrons are present. So 4 plus 3 for hydrogen, 1 each, and nothing is there. So 7. Now see, 17 and 7. I have shown you in the table, right? So 17 minus 10 is 7. So we can say that these two are isolable. So answer is isolable. See how simple this is. But most of the questions are asked from this. Okay. Now coming to the example. Okay. So now coming to the case 2. Okay. Transition versus transition metal. Nothing complications are there. Only if we can calculate the total electron count, and this should be matched with the other one, because both of the compounds having transition metal. For example, let's say CpCO. This is a fragment. Fragment is given only here. Okay. And second one is this one. Both having the transition metal. Here CO is present. Here Ni. Fine. CO is D7 metal. So we have to take for 9 for TEC, right? TEC equal to 9 plus Cp. We know 5. So Cp ring, right? Cyclopenta, this kind of ring. This is the Cp. I hope you have not forget it. A negative sign is there. So like this. Okay. So 5. This will be 14 electron. Okay. And Ni is D8. So we have to take 10, and 2 into 2, it will be again 14. So here, as those are transition metal, we have to just compare the TEC and it should be matched. Okay. So now both has 14. So it is isolobal, we can say. Okay. Fine. The third case. Case 3 is main group element versus main group element. Fine. Here is also no complication is there. So I should take actually the case 2 and case 3 before and then case 1, right? Because that was more harder than this. So not harder, I will say a little complicated. Okay. So both they doesn't have any transition element, only carbon and like main group elements are there. So here is also the same condition. TEC should be matched. Okay. Nothing subtraction, nothing. Only TEC should be matched. Fine. Let's just find out 4 plus 1 plus 1. So it will be 6. And here 4 plus 3. Positive charge is there, so we have to subtract 1. So it will be 6. Again, 6 electron, 6 electron. Matched, TC as matched, so it will be isolobal. Iso. Okay? Easy, right? You can solve it now. So these are some questions. So let's just solve them. Phosphorus is there, fine. CH2 plus, CpCO. This is ligand, this is cobalt. These are isolobal or not? So for the 3 cases, I have to calculate. See, here non-transition metal like main group elements are also present and the transition metal is also present. Okay. So we have to take that, the first criteria, that table, right? So phosphorus is, we know, the in nitrogen group, nitrogen phosphorus. So it has 5 electron in the outermost cell or valence cell, and nothing is given, right? Why I am taking plus 0? It will be 5 electron only. CH2 plus. Okay. For C is 4. For 2 hydrogen 2 and 1 positive charge minus 1. It will be 5 electron. Fine. So see, these two have matched already. Now Cp, Co and CO. Okay. Cp means 5. Cobalt D7. We have to take D9. And CO, carbonyl, is 2. It will be 16 electron. But if we can compare it with any main group electron, it will be isolobal with what? 6 electron species. But these are 5 electron species. So what will be the answer here? 1 and 2 are isolobal. But P is not. Right? Right? I hope you have understood. Okay, let's practice more. Now, IRCO whole 3 can be replaced by which of the following fragment? See, it is actually a question of isolobal analogy, but they are asking in a different way, that it can be replaced by which. Actually, these isolobal cases or isolobal fragments can be, as they are of same symmetry and they having same electrons, right, same energy, almost same energy, so they can be actually replaced with each other. Okay, isolobal fragments can be replaced by one another. Fine. So we have to just find out that it's isolobal pair. Okay. First we have to calculate total electron count for this, right? Then we can compare it. So CrCO whole 3. Fine. So it will be what? IR is in which group? Cobalt group, right? This one. So cobalt D7. So it will be obviously D7 and total electron should be D9. sorry, not D9, total electrons should be 9. And 3 into 2, so it is 15, right? 15. So now what we can do is that 15, okay? So 15 electrons. Okay. So, and the four fragments now we have to calculate. Option A is CH2. CH2. So it will be isolable with which main group element? 5, which have 5 electrons. Let's just count that. So it is 4 plus 2. It is 6 electron. So 1 will be not the option. Now B. B is CH. 4 plus 1. It is actually 5 electron. So these two we can compare. It will be actually isolable. But let's just see other options also quickly. So CH3. CH3 means 4 plus 3. It is 7 electron. It will be not the option. And C is only 4 electron, but here it is 5, right? So you have to calculate the total electron count very carefully. If we missed 1 electron also, the answer should be changed, will be changed, right? See, in the option 6 electron, 4 electron, all are given. So you have to calculate it in very careful manner, okay? So B will be here the correct option. Now previous year questions. So it is asked in CSIR-NET December 2016. According to isolobal analogy, the right set of fragment that might replace this one in this. So here fragment is also given. The molecule is given, obviously. So molecule is CO4, CO12, right? If we can divide it with 4, it will be obviously this one. For each cobalt, there are 3 number of carbonyls, okay? So, but here we don't have to do anything because the fragment is already given. They actually made that easier for us, right? And isolobal analogy is obviously this is also written, right? We don't have to think anything here. So just we have to find out the right set. So for that we have to calculate the TEC for this first. CO whole 3, 7 cobalt is G7, so 9 plus 3 into 2, which is 6, and 15 electron. Okay, so it will be isolable with, if it is transition metal, if we compare with, because in the option transition metals are also there, so 15 it will be isolable with, or if the main group element is given, that time 5 electrons. This is fine. So first option. See, each option has 3 options. Each option has 3 parts, 3 molecules. Okay, so we have to calculate for each. CH 4 plus 1, 5 is matching, but 3 of the one option, first option should be matched. BH, boron is boron carbon, right? So boron is group third element, right? So it is 3 and 1, which is 4. So BH here not matched. So if it is matched also, this will not be the correct option, because to be a correct option, those 3 parts, all the parts should be matched with this. All the parts should be isolable with this. So it is not a correct option. Let's just go to the second option. P means 5 electron, nitrogen species, it is isolable. Okay. Then CH 5 electron, right? 2 have matched, these 2. And the third part is eta 5, C5, H5. Nothing, this is nothing but Cp. Okay. So nickel is D8. So we have to take 10 and 5. So this is 15. So see, matched, right? Matched. And this for main group element, this will be 5. So it has matched. So 2 will be the correct option. Don't just stop here. I will stop here, but you don't. You have to calculate these 2 also. Okay. Practice more, please practice more, so that you have the idea and the speed will be increased. Okay. So now this is a question comes in CSIR-NET June 2016. and it is given this fragment is given, simple, and the fragment has a twist, aim is given. Okay, CPM, we have to find out that what is the aim, right? So this fragment is isolable with BH fragment, so one is given obviously, so we just find out first the BH total electron count. So it is 3 plus 1 4, and second one is obviously the if it is a transition metal, it will be isolable with the 14 electron species, right? Or if it is a main group element, only the four electron. Okay, two are the options. So first one has Cp germanium. So germanium, okay, it is a what? Germanium is a in carbon. Okay. Germanium. So carbon. What was there? Carbon, silicon. Yes, it is in carbon. I have checked also. Okay. So carbon group. So it will be 4 plus Cp means 5, right? And for the option also. Okay. Let's just talk about the option. Okay. Here it will be 9. It will be not matched with this one, right? So let's forget about the this one option. Okay. Second has CPMN. So see CP. Okay. CPMN. Let's just count that. Okay. CPMN means 5 plus, this is D5 system, this will be 7. This is 12 electron. So will be also not the correct option. 3 is CPRU, right? RU means RU is in Fe group, right? So it has the same electron in the outermost, like the total the valence electron should be same, right? So Ru has electron, Ru has this is D6, so it will be D8, so total electron will be 8 plus 5 means 13. It is also not matched. 4 is CpCO, which is 5 plus 9, right? So now you can see 14 electrons. So these and these are matched. So this will be the correct option. Now, oh, okay. Okay. This is also a CSIR-NET question. So among the following species, isolable to CH2 are. Okay. So here more than one option is correct. So we have to first find out that what is the uh, total electron count for CH2. We have done it in many times. 4 plus 2, that means it is 6 electron, right? So here only transition metals are given. So for the transition metal, the total electron count should be 16 for the isolable, to be the isolable pair. Okay. So A is Cp, Cr, CO2, right? Cp means 5, Cr means 6, D4 system 6, and this will be 4. It will be 15 electron. So it will not be the correct option. Okay. The options having A should be now eliminated. This and this. Okay. These tricks are actually helpful in the exam. So please carefully just see it. So B, now B has Cp, Cu. Okay. This is 5 and Cu is D9, 11. It will be 16 electron. See, it is isolable with this, right? So B should be one of the option, but both the options has B. So let's just forget about that. C, NiCO whole 2, D8 system. So electron is D10, means not D10, 10. So and 4 for 2 carbonyl, it will be 14 electron. So right, so it is also not isolable. So C should not be the option, but C is in both options. Something is actually missing here, I think. So I should. This is obviously the correct thing, right? Because CH2, 4 and 2, 6, 16 electron we need. So for nickel, we know that maybe it is whole 3 was there. Something wrong is there in the question. Okay, it's just C. So this is D8. I'm just checking once again. So this is D8 means D10 and this is 4, 14. This should not be a option. And the first option I'm checking again. CP5. CR means this is 6 and 4. So 15, right? So this will be not a option. Let's just see the D option. So D is actually CR, CO whole 4. CR means 6. CO carbonyl. So this will be 8. Okay. This is again 14. Fine. Now E option. In the E option, Fe, CO whole 4. Okay. So Fe means here 8 and 4 carbonyl 8. This is 16. So only B and E is the correct option. I can see the option where B and E are there. This is only C option, 3 option, right? But here C is also given. I think here they have made some mistake. This will be whole 3, I think. Okay. So B and E, you can see this is 8, 8, 16, right? And the other one was CPCU 11 plus 5. Okay. So this you can see this is correct. So from this also we can say this third one is correct. Okay. So that's all. Okay. I have solved many questions. There are many previous year questions are actually left, but the type is actually all the kind of all the types I have shown to you, and I have solved in front of you. So just make sure that you study it carefully. You have understood the topic and just practice it more. Okay. So see you in the next topic, next session. So stay tuned. Thank you for listening. Bye.